Each I/O device will also be identified with a device number and a volume serial number. In the same way that our laptop will use drive letters to identify a disk, the device number is used in the Z-Series systems. This is necessary since over 65,536 devices can be connected, and there must be a means of identifying which particular device we need to communicate with. Even small data centers may have in excess of several thousand disk drives holding their data. So in this example, we see that the printer has one specific device number, while the disks and tapes have a range of numbers representing all the devices available for the operating system use from this particular piece of hardware. So in the case of the disks in this example, we would have 64 devices defined, which would each be a unique volume serial number. Switching our focus now to look at the external hardware devices, we begin by considering disk drives, which may be a bit confusing because of how these devices are supported as if they were still older disk models. This should not be interpreted as a negative trait, but rather as a way of standardizing usage to avoid continuous modifications to support changes in external hardware. While we will examine some of the specifics associated with disk drives in a later module, it is important to note that one of the primary objectives in Z architecture is the preservation of backward compatibility. In other words, things that may have been written 50 years ago will largely continue to run unmodified in today's environments. Similarly, when we consider the evolution of disk technology, the original disks were actually a stack of platters providing multiple recording surfaces. The last such implementation was the IBM 3390 disk access storage device. Some of the relevant terminology was the concept of a track, which represented the data that could be stored on a platter surface for one full rotation of the disk. A cylinder was the collection of tracks that were positioned directly at above and below each other so that the read-write head mechanism would not have to be moved. Each track could hold 56,664 bytes of data, while 15 tracks made up a cylinder. There were various models introduced with differing capacities ranging from 1 gigabyte to 27 gigabytes of storage capacity. This picture is a cutaway of a 3390 disk so that the individual platters can be readily seen, as well as the actuator arm which is responsible for moving the read-write heads across the disk surface. You can also see how the read-write heads are positioned as a single unit, which is what gave rise to the definition of a cylinder as being that portion of the data where the read-write heads are positioned directly above and below each other. Modern disk technology involves using arrays of disks, in which is referred to as RAID, or the redundant array of independent disks. There are numerous implementations with features providing mirroring, sophisticated error detection and correction mechanisms, and redundancy. The specifics don't particularly matter at this point. However, the relevant part is that these new disk technologies emulate or pretend to be 3390 disk drives. In other words, the operating system still interacts with and sees these devices as the much older 3390 disks. This is achieved by configuring the RAID devices as logical volumes, each assigning a volume serial number, which is like a label. Each volume is equivalent to a 3390 device, which is how it is referenced, and which is also explicitly assigned a device number so that it can be located for I/O operations. Again, this does not have any negative performance impacts and is done to avoid massive data conversions that are associated with modifying disk geometries. Basically, when data is organized in particular ways, then when the device design changes, data must be reorganized to reflect the new design. If not, then it may result in wasting space and poor performance on the device. As a result, to avoid the conversion of hundreds of thousands of files, it is simpler to allow various disk technologies to be implemented based on a particular hardware design a vendor chooses, while maintaining the image of being a 3390 to the operating system. This provides a de facto standard of interfacing to these systems. In fact, this is a technique that is often employed when programs may be designed to interface with a particular piece of equipment that is subsequently replaced. Since newer technology implementations may be quite different, it is often easier to simply emulate the older device than to change the software supporting it. This is almost like the concept of virtualization, where the underlying technology is essentially hidden from the application or the user. In the same way that we don't concern ourselves with the technology supporting the cloud, we don't have to concern ourselves with the underlying technology employed in disks, as long as we have a way of still doing what we originally wanted. A modern disk array such as the IBM DS8000 has a capacity of up to 3 petabytes, or 3 million billion bytes of data.